In this video, I'm going to show you how to solve for unknown values when you are dealing with similar triangles. Now, one strong recommendation I have for you. If you have overlapping triangles, like the ones that we are looking at right here, I recommend that you redraw them separately. So I'm going to trace the small triangle right now. And I'm going to sort of drag that over here to the side. Now I'm going to trace the large triangle. Okay, dragging that off to the side. All right, let's label this up and see what we've got. So the small triangle is BXY. So here we have BXY. And then the large triangle is BAC. So we're going to have BAC. All right, now let's label the sides. So see this 2x plus 7? That's bx. So I've got 2x plus 7. And the 72, that's right here, 72. Now, you know what? Okay, there's nothing wrong with what I'm doing, but I just realized that this is a case where we could do the side-splitter theorem. So I'm just going to continue with this, but then at the end I'm going to show you how, in this particular case, it would have been a little bit quicker to do the side-splitter. Anyway, so looking at the large side AB, that's going to be this plus this. So we're really just combining like terms. So we're going to have the 2x, but then the 56 and the 7, those are like terms. So that's going to be 63 if you add those together. All right, in the same way, side BC is going to be what you get when you add these two together. So 72 plus 84, that's going to be 156. Now you want to pick one of these triangles to be new. It doesn't matter which, and you're going to pick the other one to be old. So make sure when you set up your equation, you do new over old equals new over old. Okay, now, of course, these are corresponding sides, and these are corresponding sides. All right, those are pretty easy just to glance at and see how they match up. So when we do new over old, first I'm going to do the yellows. So new over old with the yellows would be 2x plus 7 over 2x plus 63. Now, new over old with the blue would be 72 over 156. Okay, now we're going to cross multiply. So if we do this diagonal, don't forget that you have to do the distributive property. So I'm going to take 156 and I'm going to multiply it times 2x and times 7. So that's 312x. Now 156 times 7 is 1092. All right, now we need to multiply this diagonal. And again, I am doing the distributive property. So I'm going to take this 72 and I'm going to multiply it times the 2x and the 63. Okay. So we get 144 x and then 72 times 63. That's 4,536. Okay, let's get these x's together by subtracting 144x from both sides. So that's 168. So we have 168x plus 1092 is equal to 4,536. Of course, now we will subtract 1092 from both sides. Okay, so I'm going to subtract 4,536 all right, minus 1092. All right, 3,444. Okay, don't you just love these big numbers? So now I'm going to divide both sides by 168. And we get 20.5. So x is equal to 20.5. All right, let's just double check that, yes, we were only asked to find x, so that's it, we're done. Now, I mentioned something called the Side-Splitter Theorem. So that's another way that we could have done this. Because the bases are not involved, the xy and the AC are not involved, it's just the sides. We could have done it this way. Let's see. I'm going to color this side of the line yellow, and I will color this side of the line blue. So instead of separating this into two separate triangles like I did over here, whenever you're just dealing with the sides being split in some way, then what you can do is just use these pieces directly. All right, you can use the parts of the sides. So instead of drawing the triangle separately and doing this new over old equals new over old, it would have been a little bit quicker and easier if I had simply done 2x plus 7 over 56 equals 72 over 84. All right, if we were to solve this equation in a similar way we did this, we would get the same answer. So watch out for the side-splitter theorem. If it shows up again, this is the method that we'll use next time. On the next problem, the triangles are already separated for us, so we don't have to worry about that. However, it's important that we look very carefully to see which sides are actually corresponding sides. So, for example, this x minus 2, this is side JL. So I'm looking at my similarity statement. Here's J and here's L, the beginning and the end. That's going to correspond with MJ. All right, and here's MJ over here, so that means that these are corresponding sides. So probably the 70 and the 10 are corresponding, but let's check. 10 is KL, and here's KL, so that will correspond to MN. And sure enough, here's MN. So these blues are corresponding. So let's pick one triangle to be new, and we will pick the other triangle to be old. And we will make sure that we set up our equation in the form new over old equals new over old. So I think I'm going to just squeeze this right in over here. So looking at the yellows, new over old is going to be x minus 2 over 6x plus 1. Now the blues, new over old, will be 10 over 70. So it is time to cross multiply. Look at this diagonal. And don't forget that we need to do the distributive property. So I'm going to take this 70 and I'm going to multiply it by both of these. So that's going to give me 70x minus 140. And now let's look at the other diagonal, which goes like this. So this time I'm taking the 10 and I'm multiplying it by both of these. So that's going to give me 60x plus 10. All right, let's get these x's together by subtracting 60x from both sides. So that'll be 10x minus 140 is equal to 10. Adding 140 to both sides, I'm going to get 10x is equal to 150. And then if we divide both sides by 10, I'm going to get x is equal to 15. Is that all we were being asked to find? Yes, solve for x, that's it. Okay. Be careful because this one has an extra step. We're going to solve for x, but then we're going to plug it in to find DE. So watch out for that extra step. Let's start by matching up our corresponding sides. X plus 3, that is EF. Here's EF right here. That corresponds with VT. And here's VT right here. So you might have thought that this x plus 3 would match up with the 17 because they're both on the right, but I guess they're more like mirror images of each other. So you have to use your similarity statement to be sure which sides are actually corresponding. Now you can bet that the x minus 3 is going to correspond with the 17, but let's double check. Okay, x minus 3 is DE, so that's going to correspond with UV, and sure enough, here's UV. Okay, now let's pick one of these to be new and one to be old. All right, I'm going to pick this triangle to be new, and I'll pick this one to be old. It really doesn't matter which one is which. But when you set up your equation, set it up in the form new over old is equal to new over old. Okay, so looking at the yellows, new over old would look like this, x plus 3 over 19. Now looking at the blues, new over old would be x minus 3 over 17. And then you cross multiply. So look at this diagonal. We are going to do the distributive property. I'm going to take this 17 and I'm going to multiply it here and here. So that's going to give me 17x plus 51 equals skirt. All right, again with the distributive property, people. Okay, we're multiplying 19 times the x and the 3. So that's going to be 19x minus 57. Excellent. Let us get these x's together by subtracting 17x from both sides. So that'll be 51 is equal to 2x minus 57. Now we will add 57 to both sides. All right, that's going to be 108 is equal to 2x. And then we will divide both sides by 2. And that will give us x is equal to 54. Now, this is not the final answer because we're supposed to plug it in and find DE. Okay, DE. DE is right here, y'all. Okay, DE. See it? So that's x minus 3. So that means that DE is going to equal x minus 3. So DE is going to equal 54 minus 3. Therefore, DE is going to equal 51. That is the final answer. Okay, it looks like we're just going to do one more problem on this video, and I will save the rest for part 2. Okay. Well, you know what? First, I need to match up those corresponding sides. So, look at this 4x. That's HI. HI is right here. That's going to correspond with QR. So, 4x and 10 are corresponding sides. Okay, now the 7x minus 1. That's HG. Here's HG. That corresponds with RS. Here's RS. These are corresponding. Now, label one triangle as new, and the other one is old. Doesn't matter which is which. As long as you set up your equation in the form new over old equals new over old. Look at the yellows, people. New over old will be 4x over 10. Now look at the blues. New over old will be 7x minus 1 over 17. Please cross multiply. All right, I think I'm going to do this diagonal first. Don't forget your distributive property. I'm taking this 10 and I'm multiplying it by the 7x and the negative 1. So that will give me 70x minus 10. All right, now I'm going to do the other side. 4 times 17. 68. So that's going to be 68x. Wow. Normally I would subtract the 68x from both sides because I always like to keep my x values positive. The only reason I'm not going to do that is because a lot of students get confused. If I subtract away the only thing that's here, they freak out and they don't know what to do. They don't know where to put the equal sign. The equal sign disappears. Now the reality is there would just be a 0 here and you go on with the problem. So it really shouldn't be an issue, but years and years of teaching tells me that it's better to avoid it because I don't want to blow your little minds too much. So instead, I'm going to subtract the 70x from both sides to avoid that nothingness problem. All right, if I subtract 70 from both sides, now I'm going to have negative 10 is equal to negative 2x. You guys can wrap your minds around that. So then I'm going to divide both sides by negative 2. And that's going to give me x equals positive 5. All right, is that the final answer? Yep, they just wanted us to solve for x, and we did.